Okay, so today we are going to start on hypothesis tests, okay? Without a question, this is the most difficult topic we're going to cover in statistics. I'm not saying that to scare you, I'm saying that to warn you, okay? It is, so let me just say this. Last semester when I taught this class, because we were using that other crap book, and when I taught this, I really expected a lot of questions. And so when I came back to class on Monday, they all said, "Oh, that was so easy." And I was like, okay, you just wait. But anyway, I will say this. I do think that I have a really good technique for this. This is a hard thing, hypothesis testing. We're just going to do the kind of the baby steps here at first. And so chapter 17 deals with what we call the language of hypothesis testing. Okay, now the good thing about this is there's no math today. We'll save the math for Monday, Tuesday, okay? So there's not to you, yeah. So hopefully this, so I just told you this is hard. Hopefully this first assignment is really easy, okay? I think it will be. And I even think that Tuesday's assignment will be easy. The hard part is we're going to do a lot of repetition in this class. And the hard part is when we get to step 3, which we're not going to cover today, when we get to step 3 is picking the right test. Because I'm going to teach you 4 different tests. If you were in my Math 2040 class, I would teach you 12. Okay? So you got it easy. You only have to pick out of four different tests. They get to pick 12. And so without question, hypothesis testing is the most difficult part of this class. So if you've made it this far, hopefully you'll be okay. Yes?
On our student questions tonight, do we have to do 3 definitions and 3 that are math? Because you just said there's no math today.
Well, there's no math, there's some interpretation, and we're going to go over a lot of these. So I'm going to stick with that, other than the fact that rather than saying math, I want interpretive questions. So basically, the focus of today's homework is what is the null hypothesis, what is the alternative hypothesis. So I want you to give me a scenario. I want at least 3 scenarios at a minimum, where you have to, in fact, these are the questions that you're going to ask me. Given this scenario, whatever scenario you come up with, what is the null, what is the alternative? That's one question, okay? And you can basically repeat that 3 times. Does that make sense? Emily?
Are you going to put chapter 17 is on?
Oh, I swear I did that this morning. Oh, I posted the homework, didn't I?
Yeah.
Homework. Okay, yeah, I will post that. Yeah. So I thought I'd done that. A student interrupted me this morning, and I helped him, but I got behind. All right. Now, the other thing is, because I have a feeling, I shouldn't tell you this right off the bat, I have a feeling we're going to get done a little bit early today. Now, Greg, did you get feedback from the IRB? It's been approved. Who was the other person that submitted it?
But he's not here, so I don't know if that's the got approved or not.
Oh, it was a female group. I want to say Penzie's group. Yeah, yours, I'm pretty sure it was your group was approved also. Is yours still not approved? Because there was only 2 groups that I sent. And it was Greg's, and I'm pretty sure it was McKenna's.
Well, we came to talk like a week ago just to make sure it did get sent out to them. And so, and that was like a week ago. So I'm not sure.
There was only 2. I sent Greg's and I sent McKenna's.
All right, well, I'll talk to the other 4 and see if
Okay.
I heard something about it.
All right. I think the IRB is going out of town for 2 weeks.
Oh, my goodness. Okay, you're approved.
Yeah, exactly.
All right. We still need to go through the process, but yeah, check with me after class. So I am going to give you some time now. We might talk a little bit about group projects at the end. I'll at least allow you to do groups, but this is a huge part of your group project. Okay, is doing a hypothesis test. So this is critical. You've got to understand this to do your project well. So, all right. So let me do an example here. Okay, you and a friend have a game to flip a coin. Heads, you win. The coin comes up tail, 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 tail. Is this good evidence your friend is cheating and therefore is no longer your friend? Okay? What do you think? We're just going to do this gut instinct.
I think it's cheating.
How do you decide if your friend would be cheating? We could figure out the probability that would happen, right? Okay? So this is kind of the idea. This is a really simple example. They'll get harder. But one of the things that we could do is we could say, well, what's the probability of getting 5 tails in a row? Okay? So let's think about this for a minute. This is a question you should be able to answer. Okay? What's the probability that you go tail, 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 tail? Now, could that happen just by bad luck? Could it happen? Yeah, it could happen. Okay? The probability that it comes up tails the first time is 1/2. Probability that it comes up tails on the second try, also 1/2. What do I do with those two numbers? Multiply, very good. Probability that it comes up tails on the third try. 1/2, 1/2, and 1/2. This would be 1 out of 32 chances. Okay? If I convert that to a decimal, that's 0.03125. It's going to come up about 3 times out of 100. Okay? So is it possible? Yes. Is it unlikely?
Yes.
Yes. So let me ask you, Laura and Ashley, you guys are good friends, aren't you? At least before this moment. Okay? Laura, would you feel comfortable calling Ashley a cheater?
Nope.
You don't want to ruin the friendship.
We're in a group project.
Oh. All right. Okay, so let's think about it another way. Okay, so the idea is this could happen. It's unlikely though. Okay, so this is the idea that leads us into hypothesis testing. At what point do you decide that your friend is cheating? Okay, and so in fact, maybe I'll write that here. At what point do you decide your friend is cheating? Okay? Is it 4 out of 5 heads? Would you feel, and this is probably an easy question, Caleb, if you and Greg were flipping a coin, you guys seem to be friends, right? Would you feel comfortable accusing him of cheating if it came up 3 heads and 2 tails?
Is there money on the table?
Money's on the table, $100.
Yeah, sure.
Really? 3 out of 5?
Why not test it? Because then you just get the money.
Because you just lost your friendship with him, man. You just falsely accused him of cheating. He wasn't cheating. Aren't you worried about that? You know, $100, who cares? I don't care. I can get another friend for $100. Okay? No, but seriously, would you lose a friend over 3 out of 5 heads?
I think 4 out of 5 I would, but not 3 out of 5.
3 out of 5. Wow, you're not a very nice friend.
Wow.
I'm not playing with you, that's for sure. Okay? All right. So, okay, we'll save that comment for later in the discussion. Okay? All right. So the idea here is this leads to hypothesis testing. Okay, now, one of the things that we've just done is we've done confidence intervals. Now, confidence intervals are a different way of doing a hypothesis test, okay? So you're kind of familiar with confidence intervals. We'll find out when we get our grades on Tuesday. How good you guys done that. But this is a completely different method, but it functions very similarly, okay? So we're going to talk about, first of all, the null hypothesis, okay? It's typically written as H sub 0, okay? It is a statement of no change, no difference. Or in this case, where we're talking about a coin, you're always going to assume a fair coin. Okay? So in this case, maybe I shouldn't have used 5. Let's use 10 for a minute. Okay, you flip a coin 10 times. How many heads would you expect? 5. You would expect 5 heads, right? Okay? Now, so here's some rules for your null hypothesis, okay? Number 1, it's a statement of no change, no difference, or a fair coin. Number 2, it is assumed to be true until evidence proves otherwise. Okay? So on our null hypothesis, you'll never assume that your friend is cheating. You'll always assume that your friend is not cheating. You'll always assume that they're using a fair coin. Now, if it comes up 10 heads in a row, that may cause you to question, right? In fact, let's go with that example. If we're tossing a coin 10 times, it comes up 5 heads, would you think that your friend was cheating? No. How about 6 heads? Yeah, that's pretty common. 6 and 4, right? It's pretty common. 7 heads. Most of you probably wouldn't want to lose a friend over 7 heads and 3 tails, right? Would you? Okay. 8 heads. 8 heads, you're starting to wonder, right? 9 heads. Now you're pretty sure, right? 10 heads. That seems like pretty strong evidence. Could you get, well, if you flipped a coin 1,000 times, do you think you could get 10 heads in a row? Yeah, probably would, in fact. So 10 heads isn't, it seems like it's 10 out of 10 seems pretty strong, but it is possible to get 10 heads in a row, right? And so this is the idea, is we're going to decide where do you cut that off, okay? All right, so rule number 3 on the null hypothesis, it always, and I know you guys like words like always and never, it always has an equal sign, with one exception. We're not going to talk about that today. Okay? Okay? And on today's homework, it's always going to have an equal sign in it. Okay? Yes?
What's the Chinese letter next to null hypothesis?
That's the letter H. It's not Chinese. And a number 0. Okay? All right. And you usually put a colon after it. Okay? All right. Now, here's another one. It's always about the parameter. Okay? I'm going to underline the always there, with one exception, but we're not going to talk about that exception today. Okay? Now, with the confidence intervals, we've talked about parameters, right? Somebody give me some examples of a parameter. What letter would you use for a parameter? You already took the test and you flushed all that, right?
Yeah.
Is Emily raising her hand or just stretching? Just stretching. Okay? For sure. Who knows what a parameter is? I hope you do, because you have, well,
The true value of the population.
some of you haven't taken the test yet, and you need to know it for today's
The
test.
true value of the population.
Okay, so that's good. True value of the population, but I want you to give me an example. What's an example of a parameter? I'm looking for a letter. P. P P would be an example of a parameter. Very good. Who said that?
Sarah.
Oh, 3 people took credit. All right, that's good. Okay, what's another parameter? Sigma, there we go. What's another parameter?
The weird.
The weird mu thing.
Yeah.
Greek letter mu, okay? Are there any others? Ben? Capital N. That's true. We're not going to do a populate. We're not going to do that though. That is true. Yes. R. R would be one. Okay. I should start with R. I might change my thing. I might start with R. That's a good one. I wonder if I gave you any homework on R. I don't think I did either. I might have to give you some more. What are some examples of statistics? Let me just throw this out. Okay. In fact, what corresponds to P as a statistic? What? P hat. What corresponds to sigma? What'd you say? S or X? S. What corresponds to mu? X bar. What corresponds to R? I guess you'd say R hat. Yeah, we haven't really talked about R hat, but yeah. Okay. Can you use these for the null hypothesis? No. Don't use those. You only use these letters here. Let me see if there's another one. There's actually some other ones. I think I put them in my notes, but that's from my Math 2040 class. You don't need to know about this. Okay. These are the big 4. Okay. All right. Okay. So this is null hypothesis. Now let's talk about alternative hypothesis. Okay. So I teach a lot of statistics classes. I teach out of different books. Okay. Some books use H sub 1 or H sub A. I'm going to use them interchangeably. It doesn't matter. It just only matters which book you're reading, and I don't really care. It's not a big deal to me. So you'll see me use H sub 1. You'll see me use H sub A. It doesn't matter. Okay. And the alternative hypothesis, yes, we can still see on here. I'm going to turn the camera a little bit, is a statement we are trying to prove. Okay? And it is often stated in the problem. In fact, that leads me to another rule that I didn't write on here, but I'm going to put rule number 5 back here under null hypothesis. It's often not stated in the problem, which can be a confusing thing for students because you have to figure out what it was. Oh, no, I went too low on the board. Can't see that. Okay. All right. So, because a lot of people see this, because it's usually stated in the problem, they think that's the null. No, that's the alternative. Okay. The null is often assumed. A lot of times you have to, so it's not directly stated in the problem. That's what can be confusing. Okay. Now, there are 3 types of hypothesis tests. Okay. We have here a 2-tailed test. Okay. Now I'm going to put a parenthesis. These are similar to confidence intervals. Okay. And the idea here is you're going to have some sort of a parameter equal to some sort of a value. Now the parameter, what can you substitute for your parameter? On the homework tonight, it's probably going to be P, sigma, mu. I don't know if I put any R's on there. I should have. We'll save that for Tuesday's assignment. I might have to do some R's. That's the easiest one ever. You'll love it. That'll be the easiest one. Okay? All right, and then your alternative, so this is your null hypothesis. Your alternative hypothesis is going to be the parameter does not equal some value. Okay? All right, number 2, we can do what's called a left-tailed test. Okay, you're going to have your null hypothesis, some sort of a parameter, I'm going to abbreviate that, equals some sort of a value, so it's just the same as here. The alternative hypothesis is going to be your parameter is less than some value. Okay? And then rule number 3, or type number 3, you're going to do what we call a right-tailed test. Your null hypothesis is going to be the parameter equals some value. Your alternative hypothesis is going to be your parameter is greater than some value. Okay? All right. So let's do an example. Okay? First example is a pharmaceutical company. Pharmaceutical company just developed a new antibiotic for children. Other similar antibiotics show 2% of children have a headache as a side effect. The FDA wants to know if the new antibiotic is more than 2%. Okay? So the question, so I'm going to ask you 2 questions. Number 1 is, or what is the null and the alternative hypothesis? And number 2, is it a one-tail or two-tail test? Okay? All right. I think I'm going to pick on Sydney right off the bat. Okay? So remind me again, what does null hypothesis mean? Okay, statement of no change, no difference, okay? So if this new antibiotic has no change and or is not different, what would be the null hypothesis? And oh, by the way, what was rule number 3 again? Always has an equal sign in it. I'm going to put the equals there right off the bat. Something equals something, okay? So what do you think equals what? Something equals 2%. I'm going to write the 2% as 0.02. Very good. Okay? Now, according to my hypothesis test, in all 3 cases, whether it's a two-tailed, a left-tailed, or a right-tailed, I've got to use a parameter. I'm giving you 4 parameters here, so it's multiple choice. Which is the correct parameter to use in this case and why? What'd you say? P? Why did you pick P?
Because it's not the standard deviation.
It's not the standard deviation, so she's going by process of elimination. That's a good way to go. It's definitely not standard deviation. What's R? Correlation. It's definitely not correlation. So now we're down to P and mu.
It's not is mu the mean?
Mu's the mean, right? The population mean. And 2% doesn't sound like a population mean. It sounds like a
Probability?
probability. What did you say, Jordan?
It's a percentage.
A percentage or a proportion. Yes, P is a proportion. Okay. All right, we don't want to get mixed up with probability. Probability can be a proportion, but it's a little different, okay? So, all right, so we went through here. The statement, in fact, let's go back to my sign here. The statement of no change, no difference, or a fair coin, okay? We're assuming that the new antibiotic is no different than the old antibiotic, right? 2%, okay? It's assumed to be true until evidence proves otherwise. That's actually for next week's lesson. Number 3, it always has an equal sign. She put the equal sign in there. And number 4, it's always about the parameter. These are the big 4 you're going to pick. Okay? So at least it's kind of multiple choice. Does that make sense? All right. So now, since Sydney did so well on the null hypothesis, I'm going to pick on Hannah to do the alternative hypothesis. Okay? What is the statement? In fact, let's review here. Alternative, oh, actually, kind of on here. Alternative, I'm getting some glare on here. I apologize for those of you who are watching at home, but it says here what statement we are trying to prove. What is the statement we are trying to prove? What does the FDA want to know? That's the key phrase here. The FDA wants to know if more than 2%. So how do I write that as an equation? Or an inequality, is the case may be. We're trying to prove if P is greater than 2%. Okay? All right. Does that make sense? Are you all going to ace my homework? And subsequent tests. This is the foundation for everything we do. If you don't get this right, you're screwed for the rest of the homework, for the rest of the semester, really. Okay? This is really super important. Okay? All right, I'm running out of board. Can I erase some of this stuff over here? Okay, I'm going to erase some of this stuff. Okay? Let's do another example.
The one-tailed or two-tailed?
Oh, we didn't finish that. That's a good question. Sorry, I was so excited I forgot to answer that question. Is it one-tailed or two-tailed? Whose turn is it now? It must be Amanda's turn. You got multiple choice here. Which one does it look most like? Oh, she's not just going for one-tailed. She's going for a right-tailed. Even better answer. It's a one-tailed test. It is a right-tailed test, right? Did you phone a friend for that help?
No.
No? She turned around like John told her.
I was just telling her she did a great job.
Oh, okay. All right. Great job, Amanda. All right. Okay, let's move on to another one. So these are going to be the questions. Okay? How do you know? Because I'm looking for a greater than. The right tail is always a greater than. Okay?
Sorry,
Yes.
how do you know if it's a null or alternative?
How do you know the null or the alternative?
Yeah.
So we're going back to our definitions here. Statement of no change, no difference, or it's a fair coin. Okay? The alternative is a statement we were trying to prove. The FDA is trying to prove if the new antibiotic is more than 2%. So that's the alternative. Notice that was directly stated in the problem. Was there anything that directly stated that it was 2%? Actually, there was. A lot of times there isn't. this statement here, similar antibiotics show 2% of children have headaches. A lot of times that's not stated, it's just assumed. Okay?
Wait, that isn't stated in the problem, so how do you know that it's 2%? You said that, so similar antibiotics show 2% of the children?
Yeah, and we think that this antibiotic isn't any different than the other antibiotics.
Okay.
So we're thinking ours is 2% again. Okay?
So that'll be written in the problem.
No, it usually isn't. It was written in this problem, it's usually not written. It was written here just
Can we
because
do
to help
an
you guys out.
example of where it's not written?
Yeah, we're gonna do one right now.
It's
Okay.
one's alternative, correct?
Which one's alternative?
This article.
The FDA wants to know if it's more than, that's your alternative.
Okay.
This happens to be your null.
Okay.
Okay? Let's do another one. I'll try to make this one a little harder, okay? All right. The blue book value of a Chevy Corvette is $37,500. Grant wants to know if the price is different in Miami. Okay. Seth, it must be your turn. Okay, what is the null hypothesis? Remind me what null hypothesis means.
Statement of no change.
Statement of no change, no difference. Okay, what does no change and no difference mean in this problem?
I don't know, that the car is $37,000.
Okay, you said the car is $37,500, but we've got to put, instead of the car is, we got to put it,
Equal.
so something equals. Okay, we got to have an equals in there. What equals 37,500?
The car.
Okay, don't say the car because that's not one of my four choices.
Oh,
Should we vote? Who says it's P? One in a stretch? Who says it's sigma? No? Who says it's mu? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay? Who says it's R? Okay, majority wins, it's mu. Of course, you can't do raising your hands on the test. How do we know it's mu? Seth, how do you know it's mu?
because it wasn't any of the others.
Because it wasn't any of the others. Can we be a little more specific? No?
Is it new because the average would be like, some people might sell it for 38, some people might sell it for
Okay, he
36.
used the A word, average. But he meant the mean, right? Because the idea is it's always about the population. It's always about the parameter. The parameter is always about the population. And it's a mean, so it's got to be mu, okay? This one's a mean. The previous one was a proportion, okay? So this is where it becomes critical to be able to distinguish what kind of data am I using, okay? That's what makes this, that's why there's no math today. This is all about interpretation. Can you interpret properly, okay? That's the whole point of today's thing. Because if you don't interpret properly, forget it, you ain't gonna get it right, okay? We've got to get the foundation of interpretation correct, okay? Now, the alternative hypothesis. Whose turn is it? It must be Emily's turn, okay? Alternative hypothesis, what does that mean? often stated in the problem, and can you read this? Do you have glare?
No, I don't have a glare.
Oh, it's glare on the video.
Statement, we
Are trying to
are
prove.
trying to prove.
What is the statement Grant is trying to prove?
That the car is equal to,
Grant wants to know if
if the price is different in
price is different in Miami. What does different mean?
not equal to.
Not equal to. Very good. Okay, so something not equal to something.
Not equal to
37,500. What's this letter?
Is that also an M or the mu?
Mu. It's also a mu. Okay. Now, just so you know, I'm warning you today, it's on video. A lot of people don't like to put this letter here. Because they're like, you know what I mean. No, I don't know what you mean. Okay? That only gets you half credit. Okay?
But it's a
I want you to pick the right letter here, mu and mu. The reason why is because if you pick the right letter here, Tuesday's lecture is going to be a whole lot easier. Okay? So that's why it matters. Okay? So don't be chicken. You got to pick the right letter. Okay? Let's do another one. The standard deviation of a 64-ounce bottle of detergent is known to be 0.23 ounces. A company purchases a new machine and wants to know if there is less variability. Okay. What is, actually, before I do that, is this a one or a two-tailed test? Two-tailed test, right? Okay, all right. That's going to be more useful next week, but I want you to be able to identify that right away. Emily,
Why is it 2
why is it a two-tailed test? Because it's a not equal to. Not equal to is a two-tailed test. Okay? Yes.
Maybe this is completely irrelevant, but why is it called tailed?
Oh, that's a good question, actually. It's going to be very relevant, okay? And in order to answer that question, I'm going to come up with my favorite question, WWRD. What would Rick do? Okay? Now, what are the three types of distributions that we know right now? We know a T, Z, well, really only two, right?
Yeah.
We use Z for multiple things. Okay, so here's why we want to know this. In fact, I probably should have mentioned that when we talked about this, okay? So the idea here is we're also going to learn a different distribution later, but most of the time when we're doing a two-tailed test, we're either going to do a Z distribution or a T distribution, but the T distribution looks a lot like the Z distribution, right? So if we're doing a two-tailed test, we're going to be shading both of those tails. If we're doing a left-tailed test, we're going to be shading just one tail. And if we do a right-tailed test, we're going to be shading the right tail. Okay?
What if it's in the middle?
What if it's in the middle? Okay, well, I'm going to answer that question better next week. But the idea here is you can think of these shading areas. This is your rejection region. You can think of that as your rejection region. Okay, so if you're in the middle here, that's in the do not reject. Okay, you're jumping ahead a little bit. We're going to talk more about that next week. Okay, but yeah, that's very key. Okay, so I was going to get into that more next week, but that's why we want to know. Okay? All right, let's go back to our 64-ounce bottle of detergent known to be 0.23 ounces. Company purchases new machine, wants to know if there is less variability. It must be McKenna's turn. What does null hypothesis mean?
No change.
Okay. So what does no change mean in the context of this problem?
Is that the 64?
Well, it says the standard deviation of a 64-ounce bottle is 0.23. So
It equals.
something equals, and she said it, notice you guys all like to skip that letter, don't you? Something equals 0.23. What is the letter you should be picking?
Sigma.
Sigma, because
Standard deviation.
standard deviation. Okay. Now, let's pick on Gabrielle. What's your alternative hypothesis?
It's not going to equal the value. So
Okay,
sigma
be
is
more
not gonna
specific.
equal-
Say that again.
Sigma, or no, 60, would it be 60? It's not, sigma is not going to equal 0.23.
Okay, so you said sigma is not going to equal 0.23. Who agrees with her? 1, 2. Who disagrees with her?
Maybe no, I'm
Oh,
gonna
4.
change it to a less than.
You're going to change it to a less than? Why are you going to change it
Then
to
I
a less
read the
than?
whole question.
Because you didn't read the whole question. Why did you change it to less than?
Because they want to know if it's less
They
than.
want to know if it's less variability, so it's going to have a smaller standard deviation. Okay, does that make sense?
Yep.
Okay, good job disagreeing with her, you 4 people. Okay, all right. So, oh, you know what? I posted some homework, that's just the beginning. Because I didn't give you any R's, and I'm going to give you some R's. And plus, I didn't give you this other part here, so I'm going to give you some more. The other stuff I gave you is super easy. Okay? I think it's super easy. All right. So most of your homework, the homework that I've already posted, let's put it this way. I'm going to give you a head start on it. The homework that I've already posted is coming up with the null and the alternative hypothesis. So what we've covered so far. Okay? Who thinks that's not too bad? 1, 2, 3, 4, 5, 6. Who thinks it's horrible? Oh, you're a lion. Okay, this shouldn't be too bad, okay? All right, so let's go back to our question. In fact, I'm going to pick on Caleb again since he's such a tough friend. Okay? Okay, we're going to talk about type 1 and type 2 errors. Okay? All right. So, let's talk about reality. Reality, and we're going to talk about the conclusion. Okay? We're going to come up with a little table here. So, the null is true, or the alternative is true. And then we're going to say, do not reject the null. And we're going to say, reject the null. Okay. So let's go back to our coin flip again. Okay. Now, it probably would be pretty easy to see if, okay, let's go to our coin flip. I erased it again, but we're flipping a coin, let's say 10 times, okay? So we're flipping a coin 10 times. What would be the null hypothesis? Ben?
It's a fair coin, so
It's a fair coin, so
50% chance of either.
so you think something would equal 50% or 0.5?
Yeah.
What's the something?
That would be
Is that a mu?
proportion.
Which one? Should we vote?
Let's vote.
Who thinks it's a mean, a mu? Who thinks it's a p, a proportion? Oh, you changed your mind, okay? All right, yeah, it's a p because it's a proportion. Because is this data, in fact, this might be another question that you could ask yourself. I was going to save this question for Tuesday, but we can start it today. Is my data categorical or quantitative? Okay? In the midst of a coin flip, is your data quantitative or categorical? Steve, how come you moved, man? I forgot, I didn't wear enough deodorant or what? Okay? So is it categorical or quantitative? A coin flip. It's quantitative? Or is it categorical? You all said it was P. P would indicate it's categorical. What are the categories? Heads or tails, right? So a coin flip would be categorical. Heads or tails, those are the categories. Okay? All right, in fact, let's ask that question again back here. Sounds like we need to review some stuff. Blue Book price of a Chevy Corvette is $37,500. Is that categorical or quantitative? Quantitative. Standard deviation of 64-ounce bottle of detergent is known to be 0.23 ounces. Categorical or quantitative? Quantitative, it's a decimal, right? How about this one? Pharmaceutical company just developed a new antibiotic for children. Similar antibiotics are 2%. Is that quantitative or categorical? Oh, difference of opinion. Who says it's quantitative? Who says it's categorical? I know some people said quantitative. Why is it categorical?
Because using the parameter.
That's not the correct reason.
What?
Steve, why is it categorical?
What is it? I mean,
You're always using the parameter.
on
all of them.
categorical.
Say it again.
Is it because you can't add percentages?
Because you can add percentages. If it's categorical, what are the categories? Let me ask it that way.
Either 2% or it's not.
No, it could be not 2%. That's what we're testing. It is not 2%, right? Or it's more than 2%. If it's categorical, what are the categories?
Side effects and no side effects.
Headache or no headache? Okay. So you thought that was an easy question back in chapter 1 when we did it on the first day of class. It's coming back to scare you now, right? Okay. We've learned that. Yeah, this is categorical. You either got a headache or you didn't get a headache. Okay. Now, here's what I will say. Percentages are often, but not always, categorical. Here's an example of a percentage that's not, well, actually, well, you get a decimal here. So just because it's a decimal doesn't mean it's categorical. But an example of, let's say, a mutual fund. Okay. When we're talking about a proportion, what are the values the proportion can take? How many people can get a headache? What are the limits? 0% to 100%. Okay? If you're investing in the stock market, can you get a higher than 100% return? Yes, you can. If you're investing in the stock market, can you get a lower than a 0% return? Yeah, that's why we don't invest, right? We could lose more money than we invested, right? So you could get a negative return. Okay? So a stock market would be an example of a quantitative variable that's the percent. But if you're looking at a proportion, proportions are only go from 0 to 100%. Okay? So the proportion of kids who can get a headache is anywhere from 0 to 100%. So that would be a proportion. You got a headache, you didn't get a headache. On the stock market, I invest in IBM, I get 113% return. Is that a true proportion? Is that a true proportion from 0 to 100? No. Okay? You could get a 37% return on your IBM stock. Would that be a proportion or would that be quantitative? Laura? This was supposed to be the easy homework, you guys. Quantitative, right? Okay. All right, maybe this homework will be harder than I thought. I didn't think it was that hard. Okay, so let's go back to here, okay? Going back to our coin flip. Ben told me that the proportion of heads we would expect to get on a coin flip would be about 50%, okay? Now, let's say that I'm using a fair coin, okay? Let's say I got, say, 6 out of 10 heads. Okay, do you think that would support that the coin is fair as a general rule? Yeah. Okay. So the null is true. You don't reject the null. That would be a true conclusion. Okay. Let's say that the alternative was that a person is cheating. So let's say we're counting heads. Comes up 10 heads in a row. Let's say I put a piece of tape on there so that it would always come up heads. Okay? So the alternative hypothesis might be what? Yeah, probably in this case, because we didn't define which heads or tails, we'll probably go with a two-tail test. The proportion does not equal 0.5. Okay? Let's say the results of my experiment, I get 10 out of 10 heads. Okay? You would probably feel, even Caleb wouldn't feel too bad about him accusing Greg of cheating, right? So that would probably be a true conclusion as well. The alternative is true. Greg was cheating. We rejected the null that the coin was fair, and that was a correct conclusion. Okay? So Caleb properly accused Greg of cheating, and Greg was cheating. Okay? So there's two ways you can get it right. Either the null is true and you don't reject it, or the alternative is true and you reject the null. So those are the two ways you can get it right. Okay? There's two ways you can get it wrong. Okay? Let's say, for example, that we're going to call this alpha. Okay? Alpha is what we refer to as a type 1 error. Okay? A type 1 error is when you reject the null when you should not. Okay, this is what Caleb likes to do because money's on the line. He's going to accuse Greg of cheating when Greg wasn't cheating. Because for $100 he can go buy a new friend. Okay? So he made a mistake. Let's say you flipped the coin 6 times. Greg is not a very nice friend, or excuse me, Caleb's not a very nice friend. He says, Greg, you're cheating. And Greg wasn't cheating. Caleb made a mistake. Okay? That's a type error. You reject the null when you should not. Okay? The other mistake that you can make is what we refer to as the Greek letter beta. Looks like a B. Okay? This is a type 2 error. Okay? Type 2 means you do not reject the null when you should. Okay, so we're going back to this example again. Okay, let's say that it comes up 6 heads, 10 heads. Let's say that Greg put a piece of tape on there, but it's not noticeable. Greg was cheating. Caleb said, you're my friend, I don't want to, or we should use Laura and Ashley because they were the ones who were nice to each other, right? Okay. Laura said, I don't think Ashley's cheating. She wouldn't do that to me, but Ashley was cheating. Okay. That would be a type 2 error. You don't reject the null when you should have. Okay. I'm going to add some homework onto what they've already posted that deals with type 1 and type 2 errors. I'll probably throw some R homework in there too. Okay? All right, so which is the better error to make? If you're going to make a mistake, which one's the better error? Okay, so let me do an example here. Okay, in fact, let's go back to this example here, the pharmaceutical company. Okay? I've already got my null and my alternative hypothesis here. Let's just go with this example here, okay? You're the pharmaceutical company. You have to decide if you're gonna make a mistake, which is the better mistake. So the null hypothesis is 2% of kids get headaches. The alternative is more than 2% of kids get headaches, okay? So what is the type 1 error in this case? Okay? Type 1 error says to reject the null. So we reject that p equals 0.02 when in fact p was less than or equal to 0.02. Okay? So we said essentially this is not safe. We don't want to, so this is not safe, but it was safe. Okay, now as a company, let's talk about a pharmaceutical company. You did not put this out on the market when you could have. So you're not making any money because you said it was not safe, but it really was safe. So that's the type 1 error, that's your alpha. Okay? Essentially what you're saying is you think the antibiotic is unsafe, but it was safe. So that's one mistake you could make. The other mistake, the type 2, beta is the type 2, okay? In this case, what you're saying here is you do not reject when you should. Sorry, I was behind. Okay? Essentially was you think p equals 0.02, which is safe, when p is greater than 0.02, which is not safe. So let's think about what happens now. You thought the drug was safe. You released it to the public. All these kids are getting headaches. You're going to get sued. Okay? Elizabeth, you own the pharmaceutical company. Would you rather not make money when you could have, or would you rather make money and get a lot of bad publicity?
Type 1.
Yeah. The type 1 error, typically, if you're going to make a mistake, that's the one you want to do. It's the more conservative mistake. Okay? You're not going to release something when it was safe rather than release something that's unsafe. So typically, as we're talking about this, in fact, this does tie a little bit back to Caleb's question here. I've still got this picture here. Okay. The idea here is we're going to worry more about the type 1 error. That's why we referred to it as alpha. Okay. And the rule is, if I don't give you alpha, assume alpha equals 0.05. Okay? And a lot of times I do forget to give you alpha. Okay? So just assume. So think about it this way. You can think of a type 1 error as the probability that you're wrong. If you were wrong 5% of the time and you were right 95% of the time, would you feel pretty good about that? Would you be happy with my test? Some of you are like, heck yeah, I'd like a 95, okay? So, going back to Caleb, if he properly accused Greg of cheating 95% of the time and was wrong 5% of the time, is that a bet you'd be willing to take to Las Vegas? Yeah, probably would, okay? 5% of the time you'd be wrong, 95% of the time you'd be correct. So that's probably a pretty safe bet. Okay. Now, the idea here is you can use any, this really gets into next week's lecture, you can use any alpha you want. but this is the most common. Maybe I'll just save it with that. Okay. Okay, one last thing about the conclusions. This really leads into next week's lesson, but I'll just remind you. Okay? Conclusions. You're either going to reject the null, or you're going to do not reject the null. Okay? A lot of you are going to use the A word. I'm going to pretend that's a swear word in my class. Don't ever accept. Okay? Don't use that word. And the reason why you don't accept is because of this table here. You can make two types of mistakes. So you never accept that you're correct. You either reject the null or you don't reject the null. And it's just basically statisticians are kind of anal and we don't like to be wrong. So we say there's evidence to reject or there's not evidence to reject. Because for example, let's say that it came up 7 out of 10 heads. You might be like, well, I don't know, maybe they're cheating, maybe they're not. I can't tell, okay? You would never accept that they weren't cheating because you could be wrong. Okay, you either reject the null or you don't reject the null. So we'll talk more about that next week. All right, so maybe we get done a tad bit early. So probably next week, I'm probably going to post the final parts of the project. But here's the main things that I want you to take away for as far as the project is concerned. Okay? Number one, if you haven't collected it, you can collect it, I believe. Maybe I need to talk to Jordan after class. So if you haven't collected your data, make sure you get that collected. Okay? Number two, the main things that I want you to do is I want you to create enough graphs, appropriate graphs. Okay? Those could be histograms, those could be box and whiskers, depending on the type of data you're collecting. Maybe pie graphs, bar graphs. Okay, I'm not going to tell you what data you're supposed to collect. You have enough information now where you should be able to do that properly. Okay, but I will grade you and say, oh, you should have had that in there, or that wasn't appropriate. Okay, not every graph is appropriate. So you need to use the appropriate graphs, and it depends on your data, what you're doing. Okay. Number two, I want you to find confidence intervals for your data. Okay, that was the test that, well, some of you are still taking it today. That's the test that is due today and tomorrow. If you haven't finished taking it. Okay. Number three, I want you to do a hypothesis test. Okay, that's what we're going to do in the rest of class. Okay, today was just really step 1 of 7. Okay, we're going to cover most of those steps next week. Actually, for the rest of the class. So in one sense, the class is going to get really repetitive. You're going to repeat these same steps over and over and over. Hopefully we do it enough times that, number one, you can ace my test. Number two, you can ace your project. Okay? Your project clearly doesn't have, you can't look in the back of the book and say, what should the answer be? Okay? But I'm going to grade you and see if you get those right. Okay? So those are the 3 main things. I want a PowerPoint where you kind of give me, so some demographic data. We interviewed whoever we interviewed, and they were aged, 18 to 65 or whatever. And these are the appropriate graphs that we think we should add in here that talks about our demographic data. We're going to find a confidence intervals. In both steps 2 and 3, you're going to compare to the national poll. Okay, now let me just tell you some stuff. Theoretically, these should agree most of the time. Okay, Your confidence interval, if you compare it to your national poll, should agree with your hypothesis test. However, it's not always, they don't always agree. And in some cases, you're going to either do the confidence interval wrong or you're going to do the hypothesis test wrong, and so they'll disagree. If they disagree because you made a mistake, you should state that they disagree, and you'll get more credit. You'll get credit for the one you did right, and the one that you did wrong, at least you'll get credit for comparing that they're different. Some of you are going to do both of these right, some of you are going to do both of them wrong, some of you would do one right and one wrong. So at least as you're interpreting, when you compare it to the national poll, tell me whether they agree or disagree with the national poll. Okay? Now, as far as the stratified sample, demographically, you may want to create, because we're doing freshmen, sophomores, juniors, and seniors, right? So you may want to say, oh, more freshmen support this, and more seniors do not or support this, or whatever. There could be some differences. I would like to see those highlighted. But when you're doing your confidence interval and your hypothesis test, go ahead and combine the freshman, sophomore, junior, senior into one number so that you can actually do the data. Okay? So you may find, in fact, this would not be surprising. You're doing this, you have to do for all data types. So for example, you may find that your phone poll, more people support your proposal, whatever it is, than the stratified sample. You may find less support for the stratified sample. So perhaps your phone poll agrees with the national poll and your stratified sample does not agree. So you need to do this for every one of your, I think there's 5 data collection methods, is that right? So we're doing social media, we're doing stratified, we're doing phone. What else are we doing? Whatever those 4 or 5 are. Now, the other issue is we're doing an M&M project, right? Okay. The M&M project is going to be completely different. You won't have a confidence interval for the M&M project. It doesn't exist. You will do a hypothesis test for it. That'll be the last thing that we're going to learn at the end of the semester. So you can't do a lot with that other than collect the data, and we'll do the hypothesis test towards the end of the semester. Okay? So most of you should have been approved. I'll talk to Jordan. If you haven't collected your data, collect your data, and you should at least be able to create your graphs. You should be able to create your confidence intervals. The only thing you should have left is the hypothesis test, and we're going to learn that in the next few weeks. Okay? Any questions you guys have? All right. So see you all on Tuesday.